That was so much fun. Let's do it again. Well, this time I don't have a polynomial function. It's a rational function, but here I go. Let me take two actions. Number one, allow me to remove parentheses. Number two, allow me to remove the smaller fractions embedded in the big one. You've seen this before. I'm merely going to multiply top and bottom of the big fraction by the LCM of the denominators of the smaller fractions. This is legal because I'm merely multiplying by a funky looking form of 1, but it's tremendously useful in the sense that with the distribution of this multiplication operation over that subtraction operation, I will have removed the smaller fraction embedded in the larger one. Here too, like my last example, at any stage of the game, you can stop, take a break, evaluate the limit, but you're still in that indeterminate form. Now, when these two factors are multiplied by the first fraction, that denominator cancels with this trinomial. It's merely the numerator here as well as binomial factor that are left over. On the other side of the subtraction operation, I'm getting cancellation with this denominator. In that binomial factor, what remains standing is this binomial numerator with this trinomial factor that did not cancel this time. I'm still in a 0 over 0 situation. So let me continue to massage. I think what's next in front of me is nothing more than a mess in the numerator's position. After all, these two do not cancel. This may be a factor of the entire denominator getting ready to be canceled with something upstairs, but this factor is only a factor of the first term in the numerator. This is not a factor of the entire numerator. No cancellation. Likewise, no cancellation here. But because this denominator is already a factor, and this is a fraction, then probably in the end, I should be able to cancel some factors upstairs and downstairs for that reason. I necessarily want to leave this numerator, excuse me, I misspoke. I necessarily want to leave this denominator in factored form. I will not expand it. However, because I do have two terms upstairs with a subtraction operation, I'll blow everything up upstairs, and hopefully there's some collapsing with like terms in the numerator's position. Let's see if there is. let's see what does cancel. How about these two? There's more. Here's some more. So it looks to me like there are one. You know what? I think that should be a 6xh. Looks to me like there are 1, 2, 3, 4 terms remaining. These two happen to cancel each other out as well. I did not see that. So in the end, I guess there's only 2 terms that remain standing. When I combine those, I'm left with a 7h. But now I get a cancellation with the h factor upstairs and downstairs, removing the problem child upstairs and downstairs. I am finally ready to evaluate the limit, and I'm finding that the derivative function is indeed the ratio of 7 to this binomial square.